Alright, today we will be factoring trinomials with difference of squares and sum/difference of cubes. So for the objective, students will be able to factor using the difference of squares and the sum/difference of cubes. So let's write that down. Let's go to the next page. Students will be able to factor using difference of squares and sum/difference of cubes. The essential question is going to be, what skills have I learned to help me find the sum/difference of squares/cubes? What skills have I learned to help me find the sum/difference of squares/cubes? All right, so 2 minutes in, but let's get started. So, difference of squares. A binomial with a degree of 2 is factored by difference of squares. 1, you factor out the greatest common factor. 2, you take the square root of a squared and b squared. 3, you plug in a and b into your parentheses. So, for example, a squared minus b squared is a plus b, a minus b. And you double check your work by foiling or using the box method. So, let's factor x squared minus 9. Well, a is equal to, let's look at a value of x squared. Square root of x squared is equal to x. For b, square root of 9 is equal to 3. So x squared minus 9 is going to be equal to x plus 3, x minus 3. Let's look at another example. For 36x squared, a is equal to the square root of 36x squared, which is going to be equal to 6x. The square root of 36 is 6. The square root of x squared is x. B is going to be equal to the square root of 1, which is equal to 1. So 36x squared minus 1 is going to be equal to 6x plus 1 and 6x minus 1. Factoring 2x squared minus 32, that's going to be equal to, first we have to factor our greatest common factor. So that's going to be 2 times x squared minus 16. And then we can say, for this internal term, we can say a is equal to the square root of x squared, which is x. b is equal to the square root of 16, which is 4. So 2x squared minus 32 is equal to 2 times x plus 4 and x minus 4. All right, let's zoom in a little bit. We factor 32x to the 4th minus 98. We're going to also have to factor out a 2. A various common factor is 2. If we factor a 2, we can have 16x to the 4th minus 49. Then we can evaluate the internal term. Say a is equal to the square root of 16x to the 4th. Well, the square root of 16 is 4, and x squared times x squared is going to be x to the 4th, because that would be x times x times x times x, which is going to be x to the 4th. So the square root of 16x to the 4th is 4x squared. B is going to be the square root of 49, which is equal to 7. So 32x to the 4th minus 98 can factor into 2 times 4x squared plus 7 and 4x squared, I'm going to go off the page a little bit, minus 7. Alright, so these are the factored versions. Alright, the sum or difference of cubes. A binomial with a degree of 3 is factored by the sum/difference of cubes. Step 1, you factor out the greatest common factor. Step 2, you take the cube root of a3 and b3. 3, you plug into your parentheses. Remember, SOAP. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. A cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Double check your work by foiling or using the box method. So example, x cubed minus 64. A is equal to the cube root of x cubed. B is equal to the cube root of 64. So that means the cube root of x cubed. That means a is equal to x and b is equal to 4, because x times x times x is x cubed, and 4 times 4 times 4 is 64. 4 times 4 is 16. 16 times 4 is 64. So now that we have a and b, we can say that this is a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. So what we can write is we can write x minus 4 times x squared plus 4x plus 16. And that would be our answer. Let's look at another example. We factor 8x cubed minus 27. So a is going to be equal to the cube root of 8x cubed. And that means that a is going to be equal to 2x. 2 times 2 is 4 times 2 is 8. X times x is x cubed. And then b should be equal to the cube root, sorry, so let me rewrite that. The cube root of 27, so the cube root of 27 is equal to 3, because 3 times 3 is 9, and 9 times 3 is 27, so 3 times 3 times 3 is 27. So, now that we have our a and our b, this should be equal to 2x minus 3, and then 2x squared plus 2x times 3 plus 3 squared. And so to simplify this can become 2x minus 3 times 2, and this is going to be 2x squared, so it's going to be 4x squared plus 6x, 2 times 3 is 6, plus 9, 3 squared is 9. And so notice a is 2x, so you want to put parentheses around the entire term for a and square that. So 2x, the whole term squared, is 4x squared. That's the trickiest part. This is the factored version. Factor 250x to the fourth minus 128x. So what we're going to do is we're going to have 2x. So a is going to be equal to the cube root and b is going to be equal to the cube root, but let's factor out the greatest common factor first. So we can factor out 2x here. We factor out 2x, we can have 125x cubed minus 64. So a is equal to the cube root of 125x cubed, and b is equal to the cube root of 64. So the square root of 125x cubed is going to be 5x, and the cube root of 64 is going to be 4. Let's verify this. 5 times 5 is 25, times 5 is 125, x times x times x is x cubed. 4 times 4 is 16, times 4 is 64, so 4 times 4 times 4 is 64, so 4 cubed is 64, so the cube root of 64 is 4. And this is going to be equal to 2x times 5x minus 4 times 5x squared plus 5x times 4 plus 4 squared. As we simplify this will become 2x times 5x minus 4, and then we simplify 5x squared becomes 5 squared is 25, x squared is x squared, so you get 25x squared. 5x times 4 is plus 20x, 5 times 4 is 20, and 4 squared is 16, so plus 16, and that's all one term, so we put that in parentheses, and this is our example problem. Alright, so our summary is we learned the difference of squares, and we also learned how to, so we need to find the difference of squares and find the sum and difference of cubes. Alright, that's the video.